Hi friends, welcome to all. Today we are going to see the lab activity, configure extended VLANs, VTP and DTP. First of all, we are going to design this topology as per our lab activity on this packet tracer. Here we are going to use 2960 switches. Also the entity device, PC. Also we will rename the devices. So here this is S1, this is S2, also we have S3, and we have PCA, PC-A, this is PC-B, also PC-C. Now we will cable these devices. We have to connect these switches, same devices. So here we are going to use copper crossover, and here we can see the port fast Ethernet 0/3 on S1, fast Ethernet 0/3 on S3, 0/3, 0/3, and here we can see 0/1, 0/1. I think here we connected incorrectly. We will correct it correctly. Well, and here we can see 0/3 to 0/1. Also we will connect these PCs to switches. Here we have to use F0/6. This is F0/18, and here also F0/18. Our network is ready here. Here we can see our addressing table, and we will go through the objectives now. In part 1 we will configure VTP, in part 2 configure DTP, in part 3 add VLANs and assign ports, and finally in part 4 configure extended VLAN. Also we will go through the background here. It can become challenging to manage VLANs and trunks in a network as the number of switches increases. VLAN trunking protocol, that is VTP, allows a network administrator to automate the management of VLANs. So this is what we are going to see in this lab activity. Automated trunk negotiation between network devices is managed by the dynamic trunking protocol, that is DTP. DTP is enabled by default on Catalyst 2960 and Catalyst 3560 switches. In this lab we will configure trunk links between the switches. Also we will configure a VTP server and VTP clients in the same VTP domain. Furthermore, we will configure an extended VLAN on one of the switches, assign ports to VLANs, and verify end-to-end connectivity within the same VLAN. Here we can see the required resources, 3 switches, 2960, 3 PCs, then all the Ethernet cables already we have done here. Coming to part 1, configure VTP. All the switches will be configured to use VTP for VLAN updates. S2 will be configured as the server. Switches S1 and S3 will be configured as clients. They will be in the CCNA VTP domain using the password Cisco. Here we can see those configurations, VTP domain CCNA. Also we can see the mode for the switch S2 VTP mode server, and here is the password, VTP password Cisco. Also here they given the configuration for this S1 VTP domain CCNA VTP mode client. So this S1 and S3 we are going to configure as the VTP client. Also we can see the VTP password. So we will do this configuration on our switches. First of all we will do it on the switch S2. CLI enable configure terminal, host name as S2, and here we are going to set a BTP domain as specified CCNA. Also here we can see VTP mode as a server, and we are going to set the password as Cisco. Now we will come to the switch S1. Enable configure terminal, and we will set the host name as S1. And here we are going to set VTP, domain name CCNA, also VTP mode. Here we are going to give client. Also we will set the VTP password Cisco. Now we will do it on S3. Enable configure terminal, host name as S3, and the VTP domain as CCNA, VTP mode client, and VTP password Cisco. Coming to C, verify VTP configurations by entering show VTP status command on all switches. The VTP status for S3 is displayed below. Here we can see that VTP version, then VTP version running, domain name, pruning mode. We can see all the informations here. Operating mode, configuration revision. So this show command we will give it on our switches. First of all, we will give it on S1. Show VTP status, and here we can see the details. VTP version is 2, configuration revision 0. Also we can see VTP operating mode is client, domain name CCNA. Now we will come to S2. This is our VTP server. Show VTP status, and here we can see the details. VTP version, also we can see operating mode is server, and VTP domain name. Also coming to S3, show VTP status, and here we can see the operating mode is client, VTP version, configuration revision, etc. Now we will come to part 2, configure a DTP. Step 1, configure dynamic trunk links between S1 and S2. Enter the show interfaces fast Ethernet 0/1 switch port command on S1 and S2. What is the administrative and operational mode of switch port fast Ethernet 0/1? We will verify that by giving this show command on S1 and S2. Coming to S1. Here we are going to give that command, show interfaces fast Ethernet 0/1 switch port, and here we can see the details. Here we can see administrative mode dynamic auto, and here we can see operational mode is a static access. Same thing we will verify on S2. Show interfaces fast Ethernet 0/1 switch port, and here we can see administrative mode dynamic auto, operational mode static access. Coming to B, in interface configuration mode, configure a dynamic trunk link between S1 and S2. Because the default mode is dynamic auto, we have seen that only one side of the link needs to be configured as a dynamic desirable. So here we can see the command what we have to give on the switch S1. We have to go to that particular interface, then we have to give this command switch port mode as a dynamic desirable. Coming to the configuration on S1. Configure terminal, we have to go to that interface fast Ethernet 0/1, and here we are going to give a switch port mode dynamic desirable. Coming to C, verify trunking a link between S1 and S2 using the show interfaces trunk command. So here they given the output for this S1 show interfaces trunk, and here we can see the mode is desirable and the status is trunking and native VLAN is 1. Also they given this show command on S2 and its output here we can see the mode is auto, and we can see this port also trunking automatically. Right, so we will verify this command on S1 and S2. Coming to S1, show interfaces trunk, and we can see the output here. Port is fast Ethernet 0/1. Here we can see the mode is desirable, and here the status is trunking. Coming to S2, show interfaces trunk, and here we can see that port fast Ethernet 0/1, mode is auto, and the status is trunking. Now we will come to step 2, configure static trunk link between S1 and S3. Coming to A, between S1 and S3, configure a static trunk link using the switch port mode trunk command in the interface configuration mode for port fast Ethernet 0/3. Here we can see those commands, so we will do that. Coming to the switch S1, configure terminal, we will go to that interface fast Ethernet 0/3, and here we are going to give a switch port mode as a trunk. Coming to B, verify the trunks using show interfaces trunk command on S1. Here we can see that show interfaces trunk, and here we can see the port fast Ethernet 0/3. Here the mode is on and the status is trunking. So we will check that on this S1. Show interfaces trunk, and here we can see the details. The port fast Ethernet 0/3 mode is on, it's static, and here we can see the status is trunking. Coming to C, configure a permanent trunk between S2 and S3. Coming to our topology, here we can see the link between S2 and S3. So first of all we will do it on S2. Enable configure terminal, we have to go to that interface. So here we can see the interface. It's fast Ethernet 0/3. Fast Ethernet 0/3. Switch port mode as a trunk. Now we will come to S3. This is fast Ethernet 0/1. Enable configure terminal, we have to go to that interface, that is fast Ethernet 0/1, and here the switch port mode as a trunk. D, record the commands you use to create the static trunk. So here we given the switch port mode trunk on both the switches, so that's a command what we given. Now we will come to part 3, add VLANs and assign ports. In that step 1, add VLANs on the switches. On S1, add VLAN 10. Here we can see that command. And were you able to create VLAN 10 on S1? Explain. We will try that. Coming to S1, configure terminal. Here we will create the VLAN 10. And here we can see we got a message, VTP VLAN configuration not allowed when device is in client mode. So here we cannot we unable to create this VLAN 10 on S1, and here itself we got the explanation. Whenever the device is in client mode, we cannot create the VLAN. Coming to B, on S2 add the following VLANs, because S2 is our server, so we can add all these VLANs. Here we can see those VLANs. 10 name is red, 20 blue, 30 yellow, and 99 management. So we will create these VLANs on this switch S2. Coming to the switch S2, configure terminal, we will create the VLANs. VLAN 10, name is red. VLAN 20, name is blue. We have to give a name as blue. VLAN 30, name as yellow. Then VLAN 99, name as management. Now we are going to verify this VLAN by giving this show command, show VLAN brief on S2. Coming to S2, show VLAN brief, and here we can see the details. Here we can see the VLANs what we created. Coming to step 2, verify VTP updates on S1 and S3. Because S2 is configured as a VTP server and S1 and S3 are configured as VTP clients. S1 and S3 should learn and implement the VLAN information from S2. So we have to verify that. What show commands did you use to verify the VTP updates on S1 and S3? Here we can use the show command, show VTP status. Also we can see show VLAN brief. So we will check that on this switch S1 and S3. First of all, we will verify on S1. Show VTP status, and here we can see configuration revision. Now we can see it's 8. So we configured 4 VLAN and 4 names, so that's why we got here configuration revision as 8. Also we will verify that the command show VLAN brief, and here we can see the updates. And now we will verify on the client S3. Enable show VTP status, and here we can see configuration revision 8. Also we will give the command show VLAN brief, and here we can see those VLANs updated from the server S2. Coming to step 3, assign ports to VLANs. In this step, we will associate ports to VLANs and configure IP addresses according to the table below. Here we can see the table, port assignments, VLAN, also attached PC IP address and prefix. So we will configure these informations. Here they given the sample how to assign these ports to VLAN. Here we can see on S1 configure fast Ethernet 0/6 to access mode and assign fast Ethernet 0/6 to VLAN 10. Here we can see those commands. We have to repeat this procedure for switch port fast Ethernet 0/18 on S2 and S3 and assign the VLANs according to the table above. Also we have to assign the IP addresses to the PCs according to the table above. We will do that. First of all, we will do it on the switch S1. Here we can see this PCA is connected to this port fast Ethernet 0/6. Coming to S1, configure terminal. We have to go to that interface fast Ethernet 0/6. Switch port mode as access. Switch port access VLAN 10. Now we will do it on S2. Here we can see that the port is fast Ethernet 0/18 and here the VLAN is VLAN 20. Here we can see verify that port fast Ethernet 0/18. Coming to S2, enable configure terminal. We have to go to the interface fast Ethernet 0/18. Switch port mode as access. Switch port access VLAN 20. And coming to S3, here we can see the port fast Ethernet 0/18 VLAN is 10. Coming to S3, configure terminal interface fast Ethernet 0/18, switch port mode as access, switch port access VLAN 10. Now we will assign the IP address for these PCs. Here we can see the IP address details. We will copy this address for PCA. Also we can see the prefix. Coming to PCA, desktop IP configuration. Here is the IP address, subnet to mask. And coming to PCB, IP configuration, it's a 20.1. And coming to PCC, it's 10.2. Coming to step 4, configure IP addresses on the switches. On S1, assign an IP address to the SVI for VLAN 99 according to the addressing table and activate the interface. So here they're given for S1, and we have to repeat on S2 and S3. So we will do this configuration. Coming to our addressing table, here we can see the IP address of these switches S1, S2 and S3. First of all, we will do it on S1. We will go to the interface VLAN 99 and we will set the IP address 192.168.99.1. Also the subnet mask 255.255.255.0. No shut command. And coming to S2, interface VLAN 99, IP address 192.168.99.2 and the subnet mask 255.255.255.0. No shut command. And coming to S3, exit interface VLAN 99, IP address 192.168.99.3 and the subnet mask 255.255.255.0. No shut. Coming to step 5, verify end-to-end connectivity. Ping PCA from PCB. Was it successful? Explain. We will check that. Coming to our activity, we will get the IP address of PCA. It's 10.1. And coming to PCB command prompt, we are going to ping to PCA. We are not going to get the replay because both are in different VLAN. Also we can see they are in different networks. Or request timed out. No, it's not successful. Next is a ping PCA from PCC. Was it successful? And explain. Obviously it will ping from PCC to PCA because they are in the same network and the same VLAN. So we will check that. Coming to PCC and we will ping to PCA. Here we can see we are getting the replay. Coming to C, ping PCA from S1. Was it successful? Explained. We will try that. Coming to S1, ping to PCA. Here we can see success rate is 0%. Here the ping to PCA from S1 is failed because we can see that this S1 and PCA are in different networks. And coming to the last one, ping S1 from S2. Was it successful? Explain. Obviously it should succeed, so we have to get the IP address of S1. Here we can see that. So we will ping from S2. Ping to S1. We have to get the replay because they are in the same network and the same VLAN. Success rate is 60%. We will try once more, and here we can see success rate is 100%. Coming to part 4, configure extended VLAN. An extended VLAN is a VLAN between 1025 and 4096 because the extended VLANs cannot be managed with the VTP. VTP must be configured in transparent mode. In this part, we will change the VTP mode on S1 to transparent and create an extended VLAN on S1. Coming to step 1, configure VTP mode to transparent on S1. So we have to give this command, VTP mode transparent. So from client, we are going to change the mode to transparent. We will do that on S1. Coming to the switch S1. Configure terminal. Here we are going to give a VTP mode as transparent. Coming to B, verify the VTP mode on S1 by giving this show command, show VTP status. Coming to S1, and here we are going to give that command, show VTP status. And here we can see now the VTP operating mode is transparent. Coming to step 2, configure an extended VLAN on S1. Display the current VLAN configurations on S1. Then create an extended VLAN 2000. Here we can see that command, VLAN 2000. So we will try this. Coming to S1. First of all, we will verify the VLAN configurations, show VLAN brief, and here we can see the VLANs what we created. And now we are going to configure terminal, and we will create this VLAN 2000. Here we can see invalid input detected at this 2000. Anyway, in this packet tracer activity, this extended VLAN is not supported. So in the real time we can create this extended VLAN on these switches. Anyway, here we can see verify the VLAN creation. Here we can see the output for this show command. Here is that. And finally, we got a reflection question here. What are the advantages and disadvantages of using VTP? Obviously, VTP can eliminate the need to manually manage large numbers of VLANs in a network. If a switch that is a VTP server with a higher configuration revision number is introduced in the same VTP domain, the information from that switch may adversely change the VLAN configurations of the other switches. Well, that's all in this lab activity. That is configure extended VLANs, VTP and DTP. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share to your friends. And don't forget to subscribe this channel so that you will get latest uploading video info directly into your Gmail. Thank you.